Anything. Next one. Okay. Let's wait for 4 minutes. How to setting? How to go to setting? See the options. Okay, hi guys, it's my screen telling that my bandwidth is low. Okay, so let's start. So if you all can't see anything properly, just let me know. Okay, so we saw that I equal to beta hat plus beta 1 hat plus beta 2 hat xi plus I hat. Our camera setting was on. Video off कराया तो okay नहीं? Okay, so now we are going with this knowledge, we are going to step into OLS model. Okay, ordinary least square model. Model least square method. Okay, so this method has been known for its accuracy and it's the most popular one also, right? So always we use this method. This method is what we have learned, right? So this thing we can write in another way, having this UI hat as this concept. Okay, let's write like that. Okay, so you can subject the error term and write this equation this way. Okay, so now what we are going to do is now, like in ordinary least square method, what we do is we find this and this values through an equation, right? So we are going to form an equation which will allow us to find this beta 1 and beta 2. Okay, that is what we are going to do from the OLS model. Okay, so having this as the subject only, we can do this. Okay, because for a fact that we know this sigma of ui is equal to 0, right? So we know this value. So that's why we are taking this to this side and doing this in this way. Okay, because we know this value, but we don't know this value, sigma of ui. No. Okay. So now what we are going to do is we are going to set this equation in a way that we can reduce the sigma u. Okay. Now we are going to set this equation in a way that we can reduce this sigma ui. So what does this mean? Right? Okay. So I'm just drawing a normal. These are all values, but we get regression function, right? These may not be the actual values most of the time. Most of the time, these are not equal to the actual values. But we said actual values are always lying uh, below or low somewhere. Okay. So we are going to set this in a way. I draw another one. We are going to find the line which will reduce the distance of the errors to it. Okay, we have to find that optimal line which will reduce the distance between the actual values and the line that we are estimating, right? And the sample regression function, right? So let's say we estimate a line like this. I'll just have two lines, okay? So this is one. This is number. Okay. Now it's number one line. Let's just see the differences. In number one line. Okay. In number two line, in number two line, this point, this. These are two separate lines here. Okay. So we can consider that number two is less really close to the error terms, right? Like the distances between the real values yi to the yi hat. Yeah, this is yi to the yi hat is really long. The distance is too much. But for 1, we saw that it's not very high. Like certain this point actually it falls in the line also. Yeah. Okay. So basically what I'm trying to do is I think you can understand. We want to create a line which will have the distances we have it close. Okay, we want to create a line which have distances between the yi and the yi hat really minimum. Minimum. So this line which we are going to find is from the method ordinary least square method. Okay, so that is what we mean by we are going to set this equation in a way that minimize the sigma ui hat. We are going to set this equation which will minimize the sigma ui hat. Okay. Okay. Now, when doing this, we have two problems, right? We know that this is the right because there are pluses and minuses and altogether when we add it becomes 0. And another one is that the electrons are given the same weight, right? So maybe in a data set, okay, in a data set, there are some values. I'm telling UI values, okay? There are some UI values that we have got 11, 1, 2, 7, 15, like, okay? What is the weight we are giving? We are not giving a weight for this. If it's 11, we just take this as 11. Okay? We are not giving the importance to these numbers. Right? I just have some minus values also. Okay, we are not giving the enough importance to these numbers. Okay, so now of course, obviously you can see that this 11 means the distance is too much. Okay, the UI is too much. But when comparing -1, that distance is okay, right? It is somewhat near. But do we give the proper weights for that? No, if we are following this method, this one, we will just give same weight to each and just add it. Okay, without giving the relevant importance. Okay, so what we are doing is to overcome these two challenges, these two problems, we are going to take the sigma ui at square. Okay, from that, now see the minuses will get, they are not there anymore. The minuses won't be there anymore. Then, guys, yeah, yeah. Okay, so here can you see now the too much distance is given a higher value rather than to a smaller distance, right? So here between 11 -1, what is the like the value here, it's 12, right? The distance. But here, can you see 120? So we have given more weight to the most distant. That's why we are squaring this. Okay. Okay. So if you can remember the quantity function. Okay. In quantity function, what we do is we say marginal cost is the function of quantity, right? So like that, like this, we can say sigma ui square is a function of beta 1 hat and beta 2 x, beta 2 beta. Okay. Why we are telling this? We can you remember the exogenous and endogenous variables? So there we told endogenous variables are derived from, like, it depends on some other things. So actually this UI, okay, this error term is dependent on the beta 1 and beta. Okay. So actually what we say is if what we are estimating this beta 1 and beta 2, if our estimate is not very accurate, that starts from the data collection. If you're not collecting accurate data, then this beta 1 and beta 2 are of course not very representative. Then of course your sigma ui square will be very high. Okay, so always this depends, the level of the error depends on the accuracy of beta 1 and beta 2. Okay, now what we are going to do is, now you remember in cost model again, we got the minimum point of AVC, so that find the optimal level of production that we should make. Okay, the minimum variable cost is the optimal level where we should do the production. Okay, in that level, this is the optimal quantity that we should produce to attain the lowest level of AVC. So the same thing what we are going to do, convert it to this need, to this equation. We are going to do. Now here we are only depending on the AVC. Okay, now if we say quantity, the function of AVC, then there is only one parameter. But here we have two parameters. Okay, so one is that we should find the lowest beta 1. Oh, sorry. Not lowest beta. Case lowest, as I said you earlier, lowest error. You should find the beta 1, which will which will result in a lowest error. As just like that, you should find the just like that, you should find the beta 2, which will result in the lowest error. Okay, because there are two parameters. That's why we have this program. Okay, we are going to find the beta 1. Let's say beta 1 x square stop, then beta 2 x stop. Okay, we are going to find these two, which will result in the lowest sigma ui square. Okay, so that is what we are going to do from these equations. Okay, then there are three important steps to do this. Okay, so I have put this note in the group also. The first is take partial derivatives of beta 1 and beta 2. That's the first step. Then set the partial derivatives to 0. Okay, then we solve for beta 1 and beta 2. Beta 1 hat and beta 2. So these three important steps, this is how we are going to get formula, find the beta 2 and beta 1. Okay. So for this, first let's start with the steps. You know that ui hat is equal to by I minus by I hat. Okay, if you go back to the graph that I drew the previous session, the last graph, I told you that the ui hat is actually equal to the actual value minus the value that you got from your SRS, right? So this value adjusted from the SRS. That means in the sample regression function in that line, this value is lying in the line. Okay, but this actual value, it can be higher or lower than that value that you get from the line. Okay, so this is sample results. Okay, so after this we can expand this into what? You know that this is now yi hat is given to you from beta 1 hat and beta 2 xn. Right? Can you remember? Beta 1 hat and beta 2 xn. Okay. So we are substitute this term. Yeah. Then we are going to, come to our like we want to find. Okay, we want to equate this to 0. That's what I told you earlier. We want to, find this, right? So sigma ui square. So what you are doing is you are adding a sigma and a square. You are adding two things, right? You are adding a sigma and a square. So if you do this on one side, you should do the same thing for the other side, right? So this runs from I1 to N. Okay, depends on how many sample points you have, right? That is represented by I. Then here also I runs from 1 to N by I minus beta 1 hat minus beta 2 xi. Square. Don't forget the square. We have square here now. So square here also. So I put a bracket and made it a common square. Okay. So the next step is we are going to use the chain rule to follow this step 1. Yeah. So actually, what is chain rule? I will explain you. Okay. So chain rule is now if you can see this equation. Okay. I hope it's clear. You can see this. There is a function inside this bracket, right? What is the function? Yi minus beta 1 hat minus beta 2 hat xi. This is one function. This square is a common function for the inside function. In other words, we can say this square is a outside function for the inner function. Right? So we use chain rule in situations like this. Okay, so what happens is you have a function already, but then you have something common to that square or cube or anything. Can be 3 power to the 3 power 4, anything. Okay, so if there is an inside function to that common thing. There is an outside function also. In this case, the inside function is this part. The outside function is this square. So we use the chain rule in situations like this. Okay, so I will tell you how do we do this chain. Okay, so I will erase this. Okay, so I'll just tell you an example. You have just a simple function like this: 3x plus 5, right? Y equals 3x plus 5. Okay, now this is a simple function now. It's a simple function. So you can say this is a function. If we want power to sum, this function, in other words, this is the inner function, this is the function. Right? Now, we are going to derivate this x with regards to y. We are going to derivate this x with regards to y. So, how do you do it? Derivative. Okay. This is not a partial derivative because you have only one unknown on this side, right? That's why it's not a partial derivative, it's a derivative. Partial derivative is where you have like more than one unknown and you want to derivate it one by one. Okay, I will come back. So what you will do is you have to solve the outer function first and then you have to solve the inner function as okay. So it's very easy. Now you have to take this as one. Okay. So what I mean by you have to take the outer function first is that you have to take this as it is. Okay. And this power you should take to the front. Like normal derivative, you have 9 to the power 2, x to the power 2. Then what do you do? By derivative, it will be 2x minus 1, right? So you do it. 2x Same thing. We are going to keep this as function and for this, right? So again, 3x plus 5, 7 minus. That's the first. Second part is that you put plus, okay, because there's no minuses here. So you put, no, sorry. You have to multiply. Yeah, you have to multiply, okay? Yes. Yeah, you have to multiply. Because it's power. Okay, and second you have to solve this inside, right? It is multiplying, okay? You can see later also we are always multiplying when you have a outer function out, right? Then you multiply and you solve the inside. Now in this part what you did, you solve the outside. Now you are going to solve the inside, right? So 3x. No, like this. No, this is not here. So the 1 will come here and 3 into x 1 minus 1. Okay. Now this 5 is constant is a 0. In derivatives we have learned. What are you doing? This power you are taking here and you are deducting 1 from that power. Okay, just as how you did this. Okay, but you are doing this on the inside and the constant is 0. Now what's the result? 7 3x plus 5 to the power 6 into 3. Then 21 3x power plus 5 to the power 6. 3 into sorry. Okay. So how this way kept this 0? Then okay, no problem with that. 1 into 3 is 3. X becomes 1. 1 minus 1, 0. X 0. Any power to the 0 is anything. Okay. A0 mean, B0 mean anything. 50 mean 1. Okay. So that's how you do it. So keep this in mind. You can do this. Yeah, this is like the entrance for all of the calculations that we are going to do. Okay. Now we are going to go to the step 1. Step 1 is take the partial derivatives with respect to B1 and B2, right? So now we are going to take the partial derivative for B1, right? So the equation that we ended up with is so actually I told that you are going to equate sigma ui square. Okay, I told you that we have to equate this equation to 0, right? So sigma this is derivative. Okay. Okay, so what you're going to do is now we came up with this equation now. Sigma ui at y. sigma ui hat square equals what? We came up with sigma again, sigma in brackets yi minus beta 1 at that equation. That equation we are going to equate to 0. Okay, so the next step, I will write it big small. Okay, so first what we are doing, we have to take the partial derivative now. So we are doing in respect to the beta 1 first, right? Step by step. First we are going to do it for beta 1. Then we will do for beta 2 in the next next thing. Okay. So we can expand this. We found that this sigma uy square is now this derivative sign will come, okay? Because we are going to derivate beta 1 from this, right? U yi minus beta 1 hat minus beta hat is square. Okay. So as I told you, this one we told that we are going to equate to 0. Okay. So that means if this is equal to this, then we can equate this whole equation to 0. Right? This one we wanted to equate 0. So if this is equal to this, we can equate this also to 0. Right? Now let's start with the derivation. Right? Now can you see that this function is inside? This is one function inside, and the square is an outer function to it. Right? So what we are going to do is we are going to solve the outer function first. Okay? So this square will come out. Okay? The square will come out and sigma I minus same as it is. This is the first part of that thing, first part of that derivation, right? But this is solving the outer equation. Now let's come to the inside. Okay, as I told you, we have to multiply. Okay, what about the inside? Now this y, that is a constant, right? Now we are derivating beta 1. Okay, so for beta 1, yi is a constant, right? So it becomes 0, right? And here, what happens? Beta 1, it only has power 1, but you have to minus it. 1 minus, it already has a power 1, like that. That's a fact. Okay, you have to minus it. Then this whole thing, can you find any beta 1 in this? No, right? So this also we should treat as constant. Why? Because we can't find any beta 1 in this. That's why it's a constant. Okay. Okay. So how will this come? The power on. Okay. Into what happens to this? It becomes beta 1 0. So it's minus 1. Okay. Now what you can do is this 2, it's a multiplication for the whole equation now. So we can take this side. Okay, we are simplifying. Okay. Then what we can do is minus 1, right? Rather than to minus, multiply this 1 by 1 for the, clarity, what we can do is we can take this minus to this side. So that means if sigma, this whole thing is multiplied by minus 1, of course this will become minus. You don't want to put minus 1, no? You know it. So minus yi minus beta 1 beta 2 hat is I. Okay, now it becomes like this. Now let's solve inside, right? So how will this minus sigma by I plus n beta 1 hat minus beta 2 sigma. Okay, now these are coming sigma, right? This sigma into I is sigma 1. This sigma into beta 2 xi, beta 2 sigma xi. But why it is n here rather than coming in sigma? It is n because in a regression equation, I already told you, for that sample, for that particular sample, this beta 1 and beta 1 and beta 2, they are not changing. They are constants, right? They will not change for that sample, right? So when a constant is alone, okay, now here also this beta 2 is a constant, but is it alone? This one, beta 2, is it alone? No, it's with xi, right? So you can't take a n in front of beta 2, but this constant is alone, right? So that's why we are denoting this sigma as n. Okay, sigma means what? The total of something, right? Now let's say you have now you want to yeah, like yeah. Okay, now see there are 4 facts. There are 4 times 1. Okay, there are 4. So actually the n is 4. Okay. In another way, how you can write this? 5n. If you want to take the sum of it, 5 into 4. This n is how many times? Okay, now this n, according to the sample, if the sample has 60. Yeah. The sample has 60, then you put 60. If the sample has 50 observations, you put 50. Okay, so same as this. How many are there? That's the n. And this is a constant. Okay, repeating every time. Then you put 5n, 5 into 4. Okay, so that's what's happening here. But it only applies when the constant is alone. Okay, now here, even if it's a constant, it's with another thing. That's why we can't do that. Okay. Right. So continuing from that. So you can take this minus to that side. Sigma by I and will be equal to n the 1. That's beta 2. Okay, so you take this as the first stage, right? We are going to do it in the way of simultaneous equations, right? So this is the first equation. Then so this came from what? This came from the partial derivative of beta 1. Next is we are going to do the partial derivative of beta 2. Yeah. Now we are going to do for beta hat 2. Right? So sigma u square partial derivative of beta 2, that is equal to this. This whole thing will be, this thing will be equal to this. We are going to equate this to 0. Make the partial derivative for beta 2 hat. Same thing. Of the function, we have to solve first. 2 sigma I. Okay, now solving the inside function. Oh, now can you find the beta 2 here? No. So it's a constant. Constant is a 0. Then can you find the beta 2 here? No, it's a constant. 0. Here, beta 2 to the power 1. 1 minus 1. Then this is a multiplication, right? So you will leave it as it is. This is a constant, but it is multiplied with this. Okay, so if a constant xi, okay, this xi, if a constant, if something is, if I tell you 3x, then if you want to derivate this x, this function, we already do 3 into x1 minus y. Because this constant is multiplied with x, you have to do that. Okay, so I hope that's clear. Now this will become what? This one into, no, this minus you cannot forget. Okay, so it's minus 1 into xi, right? So minus xi, right? Okay, so just like the beginning one, we are going to remove the 2 by just dividing the other side by 2, right? And we are going to take, yeah, we are going to multiply this xi into this, right? Just multiply. Minus. Now we are, for the sake of simplicity, we are going to take this minus separately. Okay. Now this is actually minus 1 into xi now. So we are going to take the minus separately and multiply only the x into this. Right. So xi by I minus beta 1 xi minus beta 2 xi square. Yep. Okay. Now we are going to remove this minus by multiplying the inside things, right? So minus sigma xi by I minus, sorry, plus, minus and minus plus. Huh? Yeah. Okay. So, uh, so plus beta 1 beta 1 sigma psi plus beta 2 hat sigma xi square. Yeah. Okay. Now here these constants are not alone. That's why n didn't come. N didn't come. It got in the form of sigmas, right? Okay, I already multiplied by minus. So this minus you want to take it here. Okay, you can make the plus. Okay. Now, if you're doing the steps very correctly, you don't have to worry about these things. Okay. You don't want to memorize also. You just do 2-3 times, then you'll be fine. Right. So this we take this as the second equation. Okay. Now compare your first equation with the second equation. Okay. Now you know how to do the simultaneous equations, right? At least one should be equal. Like in both of the equations, one component should be equal to each other. So that we can, cancel out each other, like take the values. Okay. So what we can do here is that this beta 1 had sigma xi in the second equation, and in the first equation, the first part is n beta 1 hat, right? So you can equate these to each other. Okay, by how in the first equation, is like n. So if you want to make this like this, what is missing in this one from this one comparing to this one? What is missing here? This sigma x. Okay, so you can multiply sigma x. This whole equation you can multiply by sigma x. Okay, so it becomes, I will write this part here, sigma psi sigma yi. Sorry, these are capital Y's. Okay. The capital wise, the simple wise, those are very important. Okay. Plus n beta 1 hat sigma xi plus beta 2 hat sigma xi square. Actually, it comes like xi whole thing square. Yeah, whole thing square. Okay, sigma xi whole thing square. Okay, because it's same, no? That's it. Okay, when you multiply the same thing with the other, that whole thing will be a square. Okay, so you take this as the third equation. Like in relation of what? Then next thing is your second equation. What you got? You got beta 1 hat 1 side plus third hat 1 side. You got this, and you want to make this equal to this one, right? Now, what is missing in this? This n is missing here. So, you have to multiply this whole thing by, right? So, n beta 1. So, this is the whole thing. No, no. This same, not the third. This. Okay, now you have the third and the fourth equation. Now, okay. Now you have the third and okay. So this is the third and fourth. Actually, the way third is this fourth equation came as the third, and then this third equation came as the fourth. So like I've done just the labels are different, but you get the same answer. Okay. Now you have to decide from which you are going to minus what. Okay. Now how you can decide that is you have to see. Like the easiest way is you have to see which value is bigger. Okay. Now this value is bigger or this value is bigger. Okay. Now if you like think properly, sigma xi into y, that means then y values are there. Okay. Now the multiplication of these 2 into 3, 6, like that one. Okay. Now if you multiply these and take the answers here, the addition is your sigma xi y. Okay, this addition is your sigma xi y. That will be higher than this. Okay, what's the meaning of this? Addition of all your x terms. Addition of all your x y. X into half. X into yeah. Addition of this and addition of this is what you multiply this. Okay, that's how you get sigma x and sigma. Okay. Now, if you like see also, if you do this and see, you can like you will realize that this value is something bigger than this. Okay. So you will find as 4 minus 3. Okay, you will minus this equation from the bigger equation. Okay, that's how you find it. So that you don't memorize also. You just remember you minus for the easiness, you minus from the big one. You minus the small one from the big one. Okay, so in this case, 4 minus 3. So what will happen? 4 minus 3, no? So n beta 1 minus n beta 1 minus again minus because you're minusing now. You're minusing 4, so you're minusing 3 from 4, right? Minusing. Okay. Right. Can you see the common terms? This and this will get cut. Right. So n what will remain is n beta 2 hat minus I square minus beta hat sigma x I square. Right. This will remain the same. Just one will cancel. Okay. Now, why are we doing these simultaneous equations and these long steps? We want to find the equation for beta 2 and beta 1, right? So here, beta 1 is not present, right? Beta 1 is absent. So what you can do is you can take this beta as the common factor. Our goal is to find the equation for beta 2, right? So it's easy now. You just keep this beta as it is. That's what you want to find. And you this is multiplication now, so you take this equation. That's it. Now it is multiplying here, you divide to the other side. Okay. So this is the beta 2. Okay. Now this equation is what we do all the sums. Like in statistics, we were given this equation. We just find these values in the table and do this. Right? I think you all can remember. So this is how it comes. Like this, the equation comes through this way. Okay. So yeah, I'm not giving enough time, but let's skip to the other one. Yeah, if you have any doubt, please send your doubts to the WhatsApp group. Okay, now we found the beta 2. Now it's like it's our task to find the beta 1, right? The equation. So we are going to use the first derived equation. We found n beta. Yeah. Now we are going to derive the beta. This must be found as the first equation. Okay, not the third, not the fourth, the first one, right? So what we can do easily, we can take this to the other side. N. Okay. Now, if you want to cancel this n off, you should do, you should divide this by n. Now, if you are doing something on this side, additionally, you should do the same to the other. Okay. Now you know that sigma yi divided by n is what? Pi bar minus sigma x divided by n is x. Okay. Now this is like when you have something division below. If this is the minus equation, you can solve it individually. Okay, you can solve it individually, but do not forget the sign it has. So that's what I have done. Okay, you can solve it individually. Okay, yeah. This equation also it's not very new for us. Yeah, yeah. Now this is sigma yi divided by n is pi bar. It's the mean, right? And also, I want to emphasize that this y bar and this x bar, whether it's conditional or unconditional. Okay, now sigma of yi or sigma of xi means that I part is there. That I part, if that I part is there, that means the addition of all the actual values, right? So according to this equation, this y bar and x bar are both unconditional means unconditional. Right? It's both, it's unconditional mean both. Why? Because you are adding all the yi and dividing by n, and or you are adding all the xi and dividing by n. Right? But conditional mean is not like for a given x, you calculate the mean of the y. It is not like that. All the actual I and all the actual xi you add. Okay. So I hope so I think we didn't know from this is the chain. We don't know whether can't remember we learning it from past semesters. So that was something new for me. Now there is a method to. There's a method to find the beta 2 and beta 1. Right? Beta at 2 and beta at 1. So you know that in a graph we do if you want to draw the y bar, Okay. So y bar will be a one value. No, y bar will be one value. Okay. So that one value, like, will be a horizontal line. Okay. If you want to draw the y bar on a graph, it will be a horizontal line because it doesn't have slope. It's just one value, right? Same as that, if you want to draw the x bar, it is just one value. It doesn't have slope. So x bar. Okay. Now having this in mind, let's just mark one point here. Okay. Now in terms of y, what is it? This, let's just say y I, and in terms of x, let's say x is this. Right? Now, can you give another name for this point? Okay. So what we can do is, this is x bar. Okay. So from here to here. Okay. From here to here, it's x bar. This whole thing. I mean, like, not x bar. I mean, like, this line is x bar. So you can give this. Okay. So if you want to, write this distance, you can write like this distance. You can name it place. Okay. Sorry. X. X. Okay. You can denote this space as simple x. Okay. Now this simple xi is but actually this xi minus this x bar, right? Xi minus x. Capital Xi minus x bar. Okay. Likewise, this space also you can write this in a way of simple variable. And you can see this distance, right? So yi is red. So yi minus capital yi minus y bar. Okay. Now you can say it in another way. Now we know that this is xi, right? This from here, this xi. Sorry. From here to here. Okay. Okay. From here to here. Xi. You can tell it in way also. Xi equals, okay, this whole thing equals x bar plus. Okay. Now here, y also you can tell this full thing. Okay. This full thing is actually yi. Okay. Up to this. So you can tell. Okay. So from this, we are going to build up some equations and find the beta 2 and beta 1. Okay. So I will erase this now. Okay. Now I want to remind that we are going to use this one. Okay. we are going to use this one, these two forms, okay, for our equations. Okay, so just remember these two thoroughly. Okay, now we have beta 2x, right? So actually, we are not going to find an equation. We are going to make that equation be simpler, okay? Because you know that the previous method equations were very complicated. Okay, so we are going to just make it simpler. Okay, now we can see this first equation, second, third, and fourth, right? So we are going to do these by four parts, right? So the first part is what? N sigma xi by I. So what we are going to do is, now we found some other equations for this xi by I know. So we are going to just substitute those. And let's just not take this n for now, okay? Because it's a common thing for these two, so we can and like multiply this at the end. Okay, so we are just going to take this for simplicity. For now, at the end we will multiply this, right? So we can say this only, right? Okay, clear? This we got from the previous explanation. So what we can do is keeping the sigma as it is. What you have to do, you have to multiply bar with this and x bar y bar plus x bar by I. Okay. Then after that, you have to multiply simple xi to y capital y bar. Yeah, and simplify it. So all of plus, so you don't have to worry. You just can put plus and more. So y bar xi plus xi y. Okay, now you expand this. So you know that x bar and y bar both are constants. Okay, now I told that when a constant is alone, you can in. Okay, now these constants are not alone, but this case is like both constants. When both are constants, you can put in front of it. Okay, but in this case, x is constant, but y is not a constant. So you cannot put in here, but you have to put a sigma y, x bar and sigma y. Here both are constant, so you can put n, right? So n x bar y bar plus x bar sigma y plus y bar sigma x I plus sigma x I, right? And there's the important thing here. Okay, always sigma simple xi are equal to 0, and always simple sigma yi, sigma simple yi and sigma simple xi are 0. Okay. Yeah. So like the graph like give earlier it's bar. Okay. Now just imagine this. Because we took this point earlier, it was a plus, right? Right. Yi. Okay. Xi is greater than x bar. Here yi is greater than y bar. But what about a point here? also can be yi. Subsequently, right? So here this yi is less than y. Then this xi is less than x bar. Okay. So what happens is this because of these deviations, like sometimes you can get it now. What I mean by the simple xi and simple yi are the deviations, because this is the positive side, the deviation is positive. But if it comes inside, then the deviations are negative, right? So all the positive deviations and all the negative deviations, they cancel out and they become zero, right? So that's why we tell that sigma simple xi is zero and sigma simple yi is zero. But don't get me wrong, sigma xi is still zero. Okay. Capital X, sigma capital xi or sigma capital yi, they are not zero. They represent what? The capitals represent the actual values. Okay. Remember the words, because these are very important. Okay. Capital xi tell you the actual values in the sum. Okay. Then yi, they tell the actual values in the sum. But simple xi and simple yi, they show the deviation. Okay. So you can write down somewhere xi yi. Simple. Okay. Deviation. Capital xi, capital yi. Sample net. Okay. That's why the sigmas of these are not zero, but sigmas of these ones are zero. Okay, so what happens? Wherever you see a sigma yi and a sigma xi, then you can put them as zero. Now this will generate a zero. This will generate a zero. So 0 into x bar, 0. 0 into y bar, 0. So this whole thing cancel out, these two. Then what remains? The remaining thing is nx bar, y bar, the sigma xi, I. Okay. Now don't forget the n that we did put here. Can you see any n here? No. So we can forget this. We have to finish it by multiplying by n. Okay. So we have solved the first part, right? Now this is not zero, okay? This is not zero, okay? Because, like, yeah, this is like all your xi and yi. There are some, some these ones. Then you multiply these two, right? And you get the answer, okay? And you add. That is this one. Okay. See, okay? That's why it's not zero. Okay, because now if just imagine a point here, then simple yi also minus, simple xi also minus. Okay, so in this point, if for this point, the simple xi also will be minus, simple yi also will be minus. So minus into minus, it will become plus. So actually, in this you will not get minus values when you are multiplying. Okay, because anyway, like if one of it, like if one yi, simple yi is the minus, then it means that the xi will also be minus. Okay, that you can see from the graph. When in that like that only you will not get the minus values here. So that's why it's not adding up to 0. Okay, now the second part of the equation. There's the first one. Okay, so first one done, second, third, fourth. Okay, so second, sigma xi sigma by I, right? So we can do this like sigma xi equal to x bar plus equal xi into sigma y bar equal to simple yi plus simple y. Right, then you can solve it inside one by one. Sigma, this is the constant now. Now you see this constant is alone. Right, so n x bar plus sigma xi n y bar sigma y. Right, so what do you do? N square x bar y bar plus n x bar sigma plus n. Okay. Now here also, just see whether this rule is applicable. Are there situations like that? This is not zero. Sorry. This is zero because this is the separate addition. Okay. Like you have this side. Yeah. Now you know that this is the sigma xi is be zero. Sigma yi is zero. So 0 to 0 is they cancel. Right? And here also, this is 0. This is so what remains is n square x bar. Second, yeah, you are not catching up with the writing, just look at the recording because I need to manage the time. Yeah, and also the same things I have uploaded, so you can look at those also. I'm just studying how the way it came because you can't, memorize everything now, for example. Okay, then we have third, fourth. Third is what? N sigma xi square. So we can just, keep this n aside and do this question. So sigma x bar plus simple xi square. Then x bar plus x bar. Okay. So I just, actually you can The meaning of this is 2 times the, okay. So if you multiply and see, it will be so okay, this is a constant. So nx bar plus x bar sigma xi plus x bar sigma xi plus sigma I square, right? So here is 0 and the remaining is nx bar plus sigma xi square. Now this is 0, okay, because even if it has minus values, when squaring it will be positives. Yeah, only positives, right? So this one, don't forget the end that we did earlier. So n square plus sigma n sigma xi square. Wait, so third is also done. Yeah, just wait. Okay, we can finish in 10 minutes. And then the fourth part is sigma xi whole thing square, right? So yeah, so you can, solve it inside, right? So this is the constant now. So n x bar plus sigma xi square, right? So this will be um, in square square plus sigma I. No. You can do like this. Okay, now you know that this is 0, right? So you can just cancel this inside itself and solve, right? So this is the fourth. Yeah. Okay. So what you're doing is you are solving it inside itself, because if this is 0, you can't square it, right? Okay. Now you are just going to put everything together, or what that we have found. Okay. Now you see there are a lot of common terms, right? This one and this, then this one and this, right? So you can minus this from this. Then you can minus this from this. Okay. So the remaining parts are n sigma xi by I, then n sigma xi square, right? Then you can cut the n offs, right? Then finally you end up. Yeah, this is minus, okay? Minus means simple. Okay. So actually, this is the deviation form. Okay. Now in this equation that we took earlier, can you see any simple xi or simple yi? No, it was not based on deviation, but we got this equation from deviation method. Right. So if you get any like question, they might, give a lot of information and somewhere they can give a value for this and a value for this. Okay. And maybe if they are going to give all of these values also, but it's easier for you to do this and find the beta 2. Right. But be careful. This is all things, right? Just don't mix up everything. So for example, now this is sigma capital Xi, capital Y. This is sigma simple Xi, simple Y. So, don't mix this up with this. Different, this is different. Same as this. Sigma capital Xi square, this is different. Simple Xi. Okay. So, those are some areas where you can get confused. But it's very easy. If you know the difference, it's very easy. Okay. So for the second chapter, we have finished the maths part, right? And there are many other like some theories like numerical properties, then numerical properties for the regression function. Then there is another one, statistical properties. Then there are some assumptions in the OLS model. Okay. Now, I think assumptions in OLS model is very important because I can remember sir emphasizing it a bit. So just study the assumptions in OLS model thoroughly, and in the reference tube they have like highlighted the only main ones in the assumptions in OLS model. So like you don't want to read it fully, it's highlighted in pink, so you can read those, and I think it will help. Oh yes. So we can finish the class till class 1 hour. And yeah, if you have any doubts, please reach me. And yeah, now I will try my best to have another one. I'm not very sure because I have some other works. So whenever I get a free time, I will surely put a class. Yeah. So thank you. Good night.
Thank you, Naushik.
Thanks a lot. You're welcome.
Thank you.
You're welcome.